Hello explorers and welcome to another video. Today we are solving part 15, day 15 of Advent of Code. And in this exercise we have a place where the oxygen is missing because there were a hull break, and we need to send our repair droid over there, and they have sent us a program to actually run this droid. We need to implement the different movement commands, and also if we move 1 we go north, 2 south, 3 west and 4 east, and then the droid can either hit a wall, that's a 0. It can repair. It can also say that it was able to move in that direction, and it can also not be able to move in that direction. Oh, it can be moved in that direction and have repaired the oxygen system. So, and we need to find that location. And then they have some examples down here. My assumption here is to add to the game that we had before with the paddles and just send different commands to that and do a little more work to my web presence, so I can actually drive the bot from my web page. So that's my attempt here. I still have my int computer that might be broken, so it might not work with this example either. It's quite late here now, so I will do one attempt at this, and if I fail I will probably post this video as is and then come back to day 15 later on if I ever get my computer working. So I'll go on to do some coding, and I'll see you when I have something that is working. Drawn this up here, and I can actually move around in this maze. There's point up here where I have the star that is the end position, and down here where I have my S, that's the start position, and I have counted the amount of how many steps I need to do. It's 216 for me. So let's try that out and see if we get the right result here. Yes, you get a gold star, I get a gold star, everybody gets a gold star. And I also believe that I might have figured out what was wrong with part 13, the other game. So I might be doing that later on as well. And let's see here. I just want to show you the map. So this was the map that I got. You see here there are a lot of intricate movements all over. These blocks here, that is things that is the actual walls of the maze. Then I have dots for everywhere where you can go. And then I have zeros for everything else, and so on. And it's quite intricate, this maze here. So you can move around and look. I was all around down here and went into a lot of dead-end parts, but the star was up here, so I finally found it. My little screen here is just that I can move up, down, right, left using the numpads here, and then I send that command over to my Java server. And if we go into the code here, first off we have the normal main program here. We can move that away. I have a port 88 that I listen to. I have a socket that I will connect to. Then I have my state, and this is the important part because I need to keep my state during the whole game. And I didn't understand that actually every time you did a connection it threw away my state, because I used the same class for the actual connection as I used for the state, which was totally wrong. So here I have my actual state. Then I will create this day 15-1 or _1 and give it a socket. So this will be created for every connection, and I create my state in the main here, and then I create a server on that port, and when it's connected it will go into this class and give it the connection socket, and then it will start a thread for that connection. And if something goes wrong it will throw that, and during the run here it will first off read the input stream and output stream. So we have a lot of streams up here, printers and so on. We have the file requested. This is actually query, so we can change that up. I used another example here, just copy pasted some code. It uses a buffer reader for the inputs and then print writer for the output. And then it will actually connect to the output stream here, so you can type something there. And I will read a line here from the input into my input. I will tokenize that input. I'm not sure if that is actually required, but I will get the method first, and then I will get the query. And that's what I will use down here. And if the query starts with -fav, I am not interested in the fav icons. I will skip that request, and then I will look for the actual input, and that is after the slash in the connection string. So if we go back to this here, I just do a localhost slash and then the actual direction. So that's the int I want in here. I get that, and then I request some new content from my state with that input, and I get some content back. This content I will just send back to the web server, Java HTTP server from Swarl. So SS Saul, so that's the person I guess that actually wrote this little example that I copied here. I add this access control allow origin, and I allow everything just to keep it very simple, that I connect from any browser and make it simple for me. I add the connection length here, and I do a printout of that, and then I flush that, and then write the content and flush that. So this is pretty much all the code I need for this very simple Java server. And the state, I have my game board here, is 50 times 50. I have the actual game board is something that I draw here. So the drawing, I have a start position in the middle of that, and then my current position is at the start position from the beginning, and I have my computer here. I have my program, and then I will copy that program into, we have seen this many times before, and then I will start the computer, and I have set this mode red, so the mode is not important for this computer, so I will not have that as my first input. Then I will create my drawing, and I will fill it with zeros. So you saw that my game board was totally filled with zeros from the beginning, and then I draw over that. And then I do my draw loop here, I believe. Yeah, so to get content, we can take that first. It takes an input, it will give that to the actual program, and then it will do the draw loop with that input. And I need that input in order to know which direction I went to. I will run the program, I get the output, and I see what was the answer of that run. So what is it? A wall? Is it the actual spot that I need, or can I move in that direction? And then I set the current y and x to the new current x and y, and then I will increment and add to increment and decrease those values in which direction I want to go first off in that switch statement. And if the answer is 0, so there's a wall, then I will set a 1 in that spot. If its answer is 1, that I can move in that direction, but it's not what I'm looking for, I will set a 2 to that direction and then move my current x. And if the answer is 2, the same goes, move my current x and then set a 3. So that's the spot we want to find. And here is my little drawing function. If I'm at the start position, draw the start. If it's the current x, draw u. So here you are. And then I'm taking my board here. If it's a 0, I will draw the 0, so nothing has been typed there yet. If it's a 1, I will draw a wall. And if it's a 2, I will draw empty space. And this is the actual leak, or what we are looking for. So this was the thing that I wanted to print out here, and then I will return that. So that's the whole state here. And let's see what the next thing I need to solve is. So I will look into that and get back to you when I have read it. Yeah, so now I have read the little thing that we need to solve here. So it was a good thing that I actually saved the full game board, because I will need that now. And the question here is, when we have actually repaired this little leak that we had, how long will it take for the oxygen to fill the area of the system? And as you saw of this map that we have over here, it will take a while, because there are a lot of empty spaces to actually fill. And and it will only fill up the spaces where there is no dots. So I have a place here that might be a problem, because I didn't explore this up here totally. So that might be an issue. I need to actually explore that part so I get the full picture. But I think I have explored the rest of the map, so I can actually fill this up and see how long it will take to be oxygen filled. So I will do some implementation, and I will get back to you when I have a solution. And I'm back, and now I have tried to figure out how long it would take to actually fill this compartment with oxygen, and what I came up with was 372 minutes. So let's try that out and see if that is correct. 327. Not the right answer, it's too high. Maybe I counted one loop too many. So let's try one less. Yeah! You get a gold star, I get a gold star, everybody gets a gold star! Yeah. So I thought a little bit weirdly there. But I came to the right conclusion in the end, and I actually made something that could print out how it actually flow through the system, and it looked so correct. I thought it must be something that I did strangely. So first off, we have my input. It's not the right one. Let's close some of these down here. We have done so many exercises now. So this is my input, and up here is my little oxygen generator, and this will flow over all of this and fill it up. And you see that I use hash marks, I use dots, I use stars and zeros to fill this out. And zeros, I have those just to see that I don't have any leaks. So I will read my game board up here, and it's a 50 times 50 in size. And I create a drawing. I read each line here, and I also have a counter for how many I have read. And then I go through, read each char here. If it's a 0, I will put 99 because that's a state that I never want to go to. Then I have walls, those are 2, and I have dots, those are 0, and I have the star, which is 1. So I will fill it all with 1s. So where there are 0s, I want to fill it with 1s. Then I have this minutes here, so it starts at minute 0, and I fill until this value isn't true anymore. So while still fill, and I increment minutes, and there's my problem that I incremented first, even though I don't know if I will do any filling. Then I say that I haven't filled anything yet. I do a new copy of the drawing so I can set the values, because if I use the same drawing and just set the values in that, then I might during my loop do multiple set operations on data that has been changed. So therefore I need a clean canvas, so I will do a copy of it. Then I will go through and check if I will draw there. If I will draw in that position, then I set that position to 1, and I say that I still is filling the area up. Then I will have this print area, a little function, and then I set my drawing to new draw, so I can do a new iteration of this, and then I print out the minutes. So let's see this print area. It's just going through all of the positions in new draw, and if it's 99, I will print a 0 again. 0, I will print the dot. 1, I will print the little star, and 2, I will print the hash mark. And I just put some extra line breaks in between there so I can see where each of the maps are checking out. And this check if I should draw is pretty simple as well. If there is a 0 in this position, I know that this is a candidate for something that I want to draw on. Then I will look on each of the north, south, east and west of this draw position, and if there is 99, I will print out that I have a leak in my map, so this is not a valid map. And if I see any leaks, I will not continue. And then I have this little function here checking that the specific position that I am in, if any of the values around it is 1, then I know that this one I can fill in, so that's true, else I return false. So that's everything I need in order to count how long time in minutes there will be to fill the area with oxygen. I hope that you found this video interesting. I hope that you learned something today. If you have any questions, suggestions or comments, leave them in the comment section down below. If you like videos like this and where we do crazy tutorials or programming challenges, or where I look at new libraries and things, then please subscribe. If you like this specific video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.